Ngozi, I think that's how I would pronounce it, Ngozi needs to send out 300 wedding invitations. Let me underline that, 300 wedding invitations. In 1 minute, she can put 6 invitations into envelopes and apply stamps to them. It takes her a minimum of 50 seconds to address each invitation by hand. If N represents the number of invitations Ngozi can prepare for mailing in 180 minutes, which of the following inequalities best models the situation described above? So over here you have 180 greater than or equal to something. It's in terms of N, in terms of the number of invitations. Is 180 greater than? This is 300 less than or equal to. This is 300 less than, right over here. Now remember what our constraint is here. Our constraint is how many can she prepare in 180 minutes? How many invitations can she prepare in 180 minutes? And so it feels like, and I haven't done the math here, that you're going to want one of them that deals with the 180. And since you can do it up to 180, that you would want not just the amount of time is less than 180, but it would have to be less than or equal to. Or 180 doesn't just need to be greater than the amount of time. It could be greater than or equal to. As long as this is equal to 180, we are fine. So without doing any math, I'm already feeling that this right over here is going to be the answer. The 300, they're getting this from the fact that there's 300 wedding invitations to make. Now, that is the absolute cap. That is the absolute cap on the total number of wedding invitations that she might be able to do, but that's not going to be, that's not the constraint that we're talking about. We're constraining her actual time here. So let's verify that we feel good about this. And it looks like they did everything in minutes, so let's do everything in minutes. So any one envelope, so let's see, in 1 minute, she can put 6 invitations into envelopes. So any one invitation, I guess I could say, how much will she spend time? How much time would she spend sticking it into an envelope and applying stamps? Well, she's going to spend 1/6 of a minute. So she's going to spend 1/6 of a minute. I'm going to do everything in minutes because these look like they're in minutes right over here. 1/6 of a minute putting any one invitation into an envelope and putting stamps on them. And then how much time will she spend writing the address? Well, she's going to spend 50 seconds to write the address for any one invitation. But if it's in terms of minutes, that's 50 out of 60 seconds in a minute. Or, so we could write this plus 5/6 of a minute. And I'm really tempted to add these because they add up to 1 to 6/6, but it doesn't look like they added them over here. So I'm going to keep them like this. So this is how much time in minutes she would spend on any one invitation. And then if she's doing n invitations, well, this is per invitation, and then you multiply it by n, so times n. This is the total amount of time she would spend if she did n invitations. And so this thing right over here has to be less than or equal to 180. So we could write it like this. We could say less than or equal to 180, or we could say that 180, or we could write that 180 is going to be greater than or equal to that. And if you distribute the n, you're going to get this thing right over here. You're going to get 180 is greater than or equal to n over 6 plus 5n. Actually, let me write it that way. Plus 5 times n over 6 over let me do that blue color, over 6, which is exactly what you have here. But it's really interesting because just looking at the choices, it actually jumped out pretty fast that this was probably going to be the one that we cared about.